Alright, what is going on, guys? Today we're going to be learning about binary search. Now, binary search is another type of algorithm that we can use that kind of is the opposite of linear search. It's much more efficient, but the drawback is that the list already has to be sorted. But we'll get more into that. Now, before I do get into the video fully, I want to say if you're not subscribed, make sure to subscribe if you are enjoying it. And also, if you are applying to internships and jobs and need more resources, check out the top link in the description. But with a sorted data set, we can take advantage of the ordering to perform a search, which is more efficient than going element by element. Let's say you're looking up a word in a dictionary called telescope. Now, you wouldn't flip through the A words and the B words by the page until you get you wanted because you know T is near the end of the alphabet. You might want to flip it near the end and see R. Maybe you jump ahead and land at V. So you can go slightly backward to find the T. Now, at each point, you know to look forward or backward based on the ordering of the alphabet. We can use this in intuition for an algorithm called binary search. So the binary search requires a sorted data set, then we can check the middle value of the data set. If it matches our target, we can return it at the index. If it's less, we can start at step one again on the right half. So um, here's a good example. So binary search, we're searching for the number 41, okay? So with 41, we know that the middle is 28, right? So since the middle is 28, we're going to have to look on the right side of this because we know that 41 is on the right side. It's greater than 28, right? Next, we'll look at 68, and we know that it's less, so we'll look at these two. Same here, we look at 58, and since it's 2, we always look at the right side, and we get 41. So it takes us 1, 2, 3, 4, like 4 searches to just get to the number 41 right there. Now we'll eventually run out of values in the list or find the target value with this. The time complexity of the binary search. So how efficient is this? In each iteration, we're cutting the list in half. So the time complexity is going to be log of n. Now, a list of 64 elements will take at most 6 comparisons because you have log base 2 of 64 equals 6. And here's another thing in CS, always use base of 2 for logs because that's just how it works generally. So you always take the log of it, and whatever you get, that's how many comparisons you need. In the worst case, we look at the middle of all 64 elements. If the middle is not equal to our search value, we look at 32 elements, and then if the new middle is not equal to our search value, we look at 16, 8, 4, and 2, and so on. When there's 2 elements, the search is either one or the other, and thus at most 6 comparisons is in a sorted list of 64. Now let's go ahead and go next, and we're gonna go ahead and take the quiz, I believe, for the linear and binary search here. So given the following list of names, Emily, Ian, Hillary, Kenny, Laura, Natalia, Nick, Patrick, Richard, Sarah, and Tim, which search algorithm would locate the name Ian the fastest? I would say probably linear search because Ian's like the beginning of the list. Now, given the list of elements, how many comparisons would linear search perform to locate a target of 89? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would do 10 because 89 is not in the list, so it'd go through the entire thing once. Which of the following lists of a binary Which of the following lists of numbers would binary search not perform correctly? Uh, Probably this one because it's not sorted. binary search, you need to sort the list first. You're throwing a birthday party at a private venue. In order to be granted entry into the party, the recipient at the venue must verify if the guest's name is listed on your personalized party guest list. One of the party guests, Nick, is very impatient. If the receptionist uses linear search to search for the names on the party list, where would Nick's name be listed so that he is granted entry into the party at the fastest rate? So let's see. It would probably be okay. Must verify the guest name is on the list. Uh, Probably at the fastest rate. Oh, where should Nick's name be listed? So probably like first on the list. Yeah, he would be found in one comparison at best. Okay, cool. What is the time complexity for linear search in big O notation? It is gonna be O of n because you're searching through the entire array. What is the maximum number of comparisons that a binary search algorithm will make when searching for a value sorted in a 1000 element list? Log of 1000, because as we saw, and then blank checks whether a given value in an element of a specified list by scanning the elements of the list one by one until it finds a match, which is linear search. Cool, we got it right. And yeah, that's gonna end the video. That was basically binary search and also the quiz that came with it. But thank you so much for watching this, and you guys have a fantastic day or night wherever you are. And again, if you're looking for jobs and internships, check out the top link in the description. I think you'll find it very valuable. But with that being said, you have a fantastic day.